Okay, let's solve down some exponential equations. To do so, what we're going to aim to do on each one of these is use the one-to-one property of exponential functions. So what that says is if you can rewrite these with the exact same base on both sides, and that being the only thing on each side, you can drop the bases and set the exponents equal to one another. So what we have here is we have 4 raised to a power on one side and 256 on the other side. What you want to do is maybe test some different powers of 4, and we tend to go for the smaller integer base as being our common base. So as we test a few different values of exponents, 4 raised to powers, 4 to the first is obviously 4, 4 squared is 16, 4 to the third, 64, and I think 4 to the fourth power should equal the same thing as 256. So we can replace the 256 as 4 to the fourth power. Now we've rewritten it so we have the exact same base on both sides. Let's drop the bases and set the exponents equal to one another. That's the one-to-one property of exponential functions. So now this resulting equation should be pretty easy to solve down. We'll just move the 5 to the other side by adding 5, and we get x equals 9. And that's our only solution for this equation. Now moving the difficulty up a little bit, you can see on this next one we have 64 multiplied by 4 to the 3x power equals 16. Again, on this one, I may just focus on our smallest integer base. So in this case, 4 is the smallest one that's raised to an exponent. So let's see if we can rewrite 64 as 4 to a power and 16 as 4 to a power. So 64, let me see, we just said that was 4 to the third power. And 16 is 4 squared, 4 times 4 gives us 16. And you can use your calculator probably to double check on these, make sure you're getting the right exponents on your 4 to a power. All right, the next thing is we're not allowed to drop our bases quite yet because of what's on the left-hand side. So on the left-hand side, we need this just to be combined together and have it as 4 raised to an exponent. So when you have the same base and everything's multiplied together over here, how we're going to combine our exponents together is you add the exponents. These are not like terms because one has an x and one does not, so we'll have to combine them together and just make them added together over on the left-hand side. Right-hand side, bringing it along, we have 4 squared still, but now we've rewritten it so we have 4 to a power on each side. We just need to drop the bases and set the exponents equal to one another. This resulting equation shouldn't be too bad, it's nice and linear. So to solve it down, we'll move the 3 to the other side. We have 3x equals -1 and divide both sides by 3 to isolate the x. So x equals -1/3 should be our solution on this one. All right, similar on this next one, you'll notice that we have 2 to a power here, 2 to a power here, but we have this 1/4 in the middle. So that can be a little bit troublesome. We can approach this a couple different ways. I'm going to approach it by thinking of it as 2 to the -3n multiplied by 1 over 2 squared is the same thing as 4. And certainly not the only way to go about this, but I'm going to rewrite that 4 as 2 squared so I can see that we have 2 to a power. Now, the next step is kind of up to you. We could either move this to the other side by multiplying both sides by 2 squared, or you could rewrite this with a negative exponent. I'm going to elect to move it to the other side by multiplying by 2 squared. I think that's the easiest way to see this. By multiplying by 2 squared, it counteracts this dividing by 2 squared. Or, 2 squared over 2 squared makes a 1. So now we have 2 to the -3n power equals, to combine these exponents together on the right-hand side and just have 2 to a power, what we're going to have to do is add these exponents together. So in combining n plus 2 plus another 2, I can rewrite this as n plus 4. Now that we have 2 to a power on each side, we can drop those bases and set the exponents equal using the one-to-one property of exponential functions. From here, we just need to get n on one side by itself. So let's move all the n's to one side. So I'm going to subtract n from both sides. That'll leave us with -4n equals 4. And to isolate n, we'll divide both sides by -4. Therefore, giving us n equals -1 with a little bit of simplifying down. All right, pretty similar on this next one. Difference though is we have 3 to a power multiplied by 3 to another power, and we don't have 3 to a power yet on the right-hand side. So let's do a little bit of work on rewriting this. Hopefully we can get it as 3 to a power on both sides. So in this case, what we're going to do is go ahead and add these exponents together on the left-hand side. So we're going to get 3 raised to the 2n plus 1 plus another, 2x plus 1 plus another x. We can combine the 2x plus a third x, get 3x plus 1 on this side. On the other side, we want to figure out 3 to what power is equal to 243. And I think if we test a few values, we get 3 to the 5th power is the same thing as 243. So you can replace 243 as 3 to the 5th. Same base on both sides. Use that one-to-one property, drop the bases, set the exponents equal. Nice linear equation. So to solve this down, let's move all the constants to one side, leave all the variables on the other side, and then divide by 3 should isolate x for us. So we get x is 4/3 is a nice exact answer. 2 more real quickly. In this next case, what we have is 625 multiplied by 5 raised to a power equals 125. So we have a couple different options here. Again, we could aim to get 5 as our common base for all of our numbers here. The 625 and the 125 we could rewrite as 5 to a power, or we could isolate that 5 to a power by dividing both sides by 625. Either way you do it, it's going to be correct as long as we are careful about our steps. So I think it makes pretty good sense that we're allowed to divide by 625 because it was multiplied by this entire side. So 125 divided by 625 is the same thing as 2/10, or that's 1/5. I like writing it as a fraction. And one of the reasons why is I can see a 5 here. If I write, instead of 2/10, I can write it as 1/5. Okay, the goal again on each one of these is rewrite it so you can see it as 5 to a power or the same base on both sides. I would aim as 5 to a power on both sides. As we see, we have 1/5 to the first power on the right side. Review over one of these exponent rules. We can move that 5 up to the numerator by making it a negative exponent. Now we have 5 to a power, so the one-to-one property says drop those bases, set the exponents equal, get to an equation we're really comfortable with solving down. So I'll quickly solving this down. I'm going to move the constants to the other side and divide both sides by 3 to isolate the x. So we're going to get to x equals -4/3. All right, one last one, a little bit more challenging. The goal on this is same idea. We want to solve for x, but if we think about this, we have 8 to a power and 16 to a power. If we want to get the same base on both sides, we're not going to be able to use 8 because 8 to the first is 8. 8 squared is 64. We jump right past the 16. So aiming for the smaller of these two bases isn't going to quite work out on this one. Instead, we have to go a little bit smaller than 8. We also can't use 4 squared is 16. We can't rewrite 8 as 4 to a power. So instead, we're going to have to go all the way down to 2 to a power, because 16 can be rewritten as 2 to the third power is 8. So since the 8 is raised to the x plus 2 power, I'm going to replace the 8 with 2 cubed. That's still going to be raised to the x plus 2 power. On the right-hand side, we can replace the 16 over there as 2 to the 4th power. Same thing as 16, but again, 16 was raised to this exponent, so whatever we replace the 16 with, the 2 to the 4th power, it's still raised to the x plus 1. Okay, from here, to combine these exponents together and just get 2 to a power on both sides, our exponent rule says you have to multiply these exponents together. Now, what you don't want to forget about is this 3 needs to be multiplied by both the exponents on the outside. So we have 3x plus 6 as our exponent on the left-hand side. And on the right-hand side, we have 2 raised to, again, that 4 needs to be basically distributed here, 4x plus 4. Same base on both sides. Let's drop the bases, set the exponents equal based on the one-to-one property of exponential functions. End up with a linear function, a linear equation, I should say. So we'll move all the variables to one side. 4x minus 3x's leaves us with an x plus 4. Move all the constants to the other side. So in this case, I'm subtracting 4 from both sides, and I end up with x equals 2. So that's our only solution to our original starting equation here. All right, I hope this helps out as we're learning about solving exponential equations by rewriting them with the same base on both sides. So we're allowed to drop the bases based on the OnetoOne property of exponential functions. Review over these exponent rules. It really pays off in this class as well as in future math classes, really being confident about those exponent rules. All right, good luck.